Hello students, welcome to ePhysics. Students, in the previous video we have discussed the algebraical derivation of equations of motions. Now here we will be discussing the graphical derivation of equations of motion. So let's start it. Now students, let us consider we have a Cartesian plane. Okay, let us consider we have this. Okay. And let us consider the object moving does not have the initial velocity equal to 0. Let us consider the initial velocity is somewhere has something u. Okay. Now, if it is u, so it will start somewhere from here, and let us, make the graph complete first. Now, let us consider, students, this horizontal axis denotes time. Okay, this vertical axis denotes velocity. Let us consider the object moving has the initial velocity u and it reaches up to a final velocity. Let us consider v. Let's name the intersecting points. Let us name it as O, A, B, C, D, and let us consider this is E. Okay, this is E. Now, here students, for the first equation of motion, okay. Now students, we have studied when we were discussing the graphical representation of the motion, that we have studied that the slope of the velocity time axis gives acceleration. Okay. So acceleration gives, acceleration is the slope of velocity time graph. Okay, so acceleration will be equal to the slope is EC. Therefore, it is equal, and it is represented by the slope is represented by BC upon EB. EB. So this is the slope. And here from the graph we can clearly see that EB is equals to OA, and OA is nothing other than the time taken. Okay, this is the time taken. So it can be written as time taken. Therefore, from equation 1, we can write A is equals to BC divided by EB, where EB is equals to T. Therefore, now we can write it as A multiplied by T is equals to BC. Let us consider this is equation 2. Now students, from the graph again we can see that this BC is equals to AC minus AB. Okay, AC, let me show it to you first. This is A to C. Okay, A to C, and minus A, this is A to C minus AB. Then we will get B to C. Okay, so this is how we will have to show it. Okay, now this can be written as BC is equals to AC minus AB, which can be written as, if AC is equals to, we have considered over here that AC is equals to B minus AB is equals to OE, which is equals to U. So this can be written as V minus U. When we put it in equation 2, we get AT is equals to V minus U. Therefore, finally, we get the equation that V is equals to U plus A T. So, this is the first equation of motion. That is V is equals to U plus AT. I hope you understood it. Let's move to the second equation of motion now. Now, let's see the second equation of motion, students. Second equation of motion. Now, students, in the second equation of motion, we were finding the distance. S is equals to ut plus half at square. And we know in the velocity time graph, the area enclosed by the slope of the velocity time graph and O and the time axis is known as the distance traveled. So, here distance traveled will be equal to area of this triangle plus area of this rectangle. So, we can write it as area of triangle, that is EBC, plus area of rectangle, area of rectangle OABE, OABE. Okay, now when we solve it, we get that S is equals to area of triangle EBC will be equal to 1 by 2 into base is equals to EB multiplied by EB multiplied by height is equals to BC, that is BC. Clear? Now it can be written as plus and area of rectangle OABE is equals to length multiplied by breadth, that is OE multiplied by breadth. Breadth is equals to OA. Now substituting the values, we get 1 by 2 into EB. EB is equals to T multiplied by BC. BC, which is equals to, students, in the first equation of motion, we have studied that acceleration of this graph, acceleration of the object will be equal to the slope of the velocity time graph, that is BC upon T. Okay, sorry, this is BC upon T. Therefore, BC can be written as A multiplied by T. So, we can put A multiplied by T in place of BC plus OE. OE ka value is equals to U multiplied by OA, which is equals to T. So, finally, we get to the conclusion that S is equals to UT plus this is half A T into T, that is T square. So, this is 1 by 2 into A T square. So, this is the graphical derivation or representation of second equation of motion. So, let's move to the third equation of motion now. Now, the third equation of motion, students, the third equation of motion. Now again, students, in the third equation of motion, we have 2AS is equals to V square minus U square. There is also a S term, that is the term of distance. And in the second equation also, we have found the area of this slope, okay, the graph so formed. And in the third equation of motion also, students, we will be finding the area. But in the second equation, we have found it as the area of triangle plus area of rectangle. But here in the third equation, we can clearly see a trapezium shape, that is OE, C, B, A. Okay, this is a trapezium shape. So we will find the area of this whole trapezium. Okay, so S is equals to area of trapezium, and the trapezium is O, E, C, A. Okay, now we know the formula of area of trapezium. It is equals to 1 by 2 into sum of parallel sides, okay, multiplied by the distance between them, and that is the height. Okay, so let's move it. We can write it as S is equals to 1 by 2 sum of parallel sides. Sum of parallel sides means OE plus AC. OE plus AC multiplied by height, that is OA. OA. This can further be written as 1 by 2 OE is equals to U plus AC. Okay, AC can be written as, AC is equals to V multiplied by OA. OA is equals to T. And students, from the first equation of motion, we have been knowing that V is equals to U plus AT. So from here, we can write it as V minus U upon A is equals to T. So we can replace T with V minus U upon A. So S is equals to 1 by 2 V plus U. Here it becomes V minus U upon A. Okay, so here in the denominator we have 2A. If we shift it on the left hand side, we get 2AS is equals to A plus B into A minus B, which is A square minus B square, that is V square minus U square. So we get the third equation of motion from here, that is 2AS is equals to V square minus U square. So hope you understood the graphical representation nicely. Thank you very much for watching the video.